All right, so this is our lab here, and we're actually starting on that access point that was in the office. Now here, we're just logging in with the basic credentials, and you want to set the host name, as we're showing here, and you want to usually keep it with the area the device is in. And in this one, we're going and securing the privileged mode access, as well as creating a user. Now, let me pause this. You want the password here to be separate from the admin password. The user, rather. You want that to be separate from those. And now we have to just secure our console line. So it has to be logged in with the credentials. You can also use Radius or TACX and have the login be authenticated from a server on the network. And those are very common in big networks, but in this case, it's small enough where we don't need that. And the VTY lines are just when we log in for management of the device. So that is how you have the management secured as well. Most of this is all the housekeeping configuration. That's the domain name here. Excuse me. And this is just setting up the SSH. For the encryption for SSH. I've decided to do this one as a voiceover to save your ears from the fan noise. So that was why we have it this way today. And that turns on SSH version 2, and the web server turns those off, since you only want the encrypted management connection to it, not the unencrypted versions. Now, with the wireless, the SSID VLANs, here we're creating our first SSID. And this is for the office staff. Okay. And after we create that, we're just setting open authentication, so there's no restrictions on who can authenticate. And this sets up the management of that key. And we're using Wi-Fi Protected Access version 2. And with that command here with the WPA PSK, we're just setting the key. The multiple BSSID is for, let me pause that again. The MBSSID is because we're having multiple SSIDs on the same radio. All right, and the guest mode means you're going to see in the beacon frames the SSID of that network. If you don't have guest mode on there, you're not going to see it. But you do need MBSSID unless you're just doing one wireless network. Now this is very important. By saying VLAN 10, it's making, essentially, it's tagging it's grouping the SSID with the VLAN. It's associating the two. So when they access the SSID there, the access point remembers that traffic is part of VLAN 10. And that's going to become very important in a second once we get to the interface configuration parts of this. The rest of what I'm doing with the management is the same, except that it is in VLAN 100. Now, very important as well, it may not be as common in all cases to actually have a management network, especially not one especially one that's radius, not radius, rather. But in this case, it was just the easiest to show you. So anyway, though, the concept, you could substitute that for a guest network as well. So now we have to go into the physical interface. And this just sets the frequency it's going to use. As well as, here we're saving the config. I save my config when I just group them together, how I feel, and then just save it there. This sets up the cipher for normal SSIDs that are in a VLAN. And this sets up a cipher for each VLAN. So we can group multiple SSIDs in VLANs and have them have different ciphers or not be encrypted, etc. So like for our guest, we could have it unencrypted. But this part, though, tells the radio which SSIDs it should broadcast. So you do need to make the SSID and enable it. And the MBSSID lets the radio manage both of those SSIDs. Now, this is very important. I want you to see I made from that one physical interface a subinterface of .10. This is the same as subinterfaces on a router, and you'll see that when we get down to the router. But this means any frame coming to or leaving the radio at layer 2 will get a tag of 10, a VLAN ID of 10, all right? Now, we're going to do this on both sides, but it's because you need to have that tag correctly identifying the wireless traffic. So it's treated the same when it goes on the Ethernet segment. All right, so now, bridge group as well. You need to put bridge group on here. If bridge group is left out, it's not going to tag the traffic correctly. So you need to tell it what, basically VLAN it's a part of. And that's also going to be very important for management in a second. Now, this here is the same as what I just spoke about, except it's VLAN 100. And remember, this has to be done on both the wireless interface as well as the Ethernet interface. So here we're going into the Ethernet interface, and we're pretty much doing the same thing. And we're also going to do the same thing on the router, so once we get to that point, you'll understand what's going on. The only difference is in the router is we add an IP. So we're making, again, those two sub-interfaces. But you have to make sure, once we finish that one, that you have, on this radio interface, you have to have a subinterface for VLAN 10 and bridge group 10. Likewise for the other subinterface on that radio. If you did this on the 5 gigahertz radio, you would do the same thing. It doesn't change how you would implement this. And do make sure to bring the physical interfaces up. So sorry, excuse me. But that brings those interfaces up. And it will take a second. It has to scan the frequencies. And it has to use DFS to find the cleanest frequency and select it. Now, this is the management interface. And we're putting the IP for management on this interface. So, in this case, 192.168.102 on the 100.0/24 network. And we have to give it a default gateway because if we're accessing this through, a VPN externally or something like that, if our IT is outsourced, it has to be able to get back through. So it's got to know how to send back to the other network. This access list is a crucial part. It is allowing only the packets sourced from the IT VLAN. And we're applying it on the VT1 lines inbound because we need only that VLAN or the subnet to talk to this AP. We don't want people from any other subnet talking to that AP. So again, I'll leave this part in as well. I'm just verifying everything. And then you see in this case, I actually forgot to remove the default username. But that's how this configuration on the access point is done. And just don't get tripped up. The thing is, you need the VLAN on the interface. on both sides, and you need to create the SSID and map it with that VLAN before you put it on the wireless interface. So you got three major things you got to remember, and don't forget the bridge group. The bridge group for that VLAN is crucial, otherwise it will not correctly work. But with that, we're going to move on to the switch next, so I will see you there. Alright, so now we're moving down from the access point, and we're moving into the switch configuration. So this is what our Ethernet clients will plug into, and the access point, and the router, and all that. Now, mainly the first few commands are all the same, how I covered them in the access point. So make sure the passwords are separate, set the host name to where the device is, secure VTY lines, and I actually didn't tell you about this command. This command, logging synchronous, its job is to prevent syslog messages from interrupting your typing. So it just, if you're typing and you're in the middle of a command, if a syslog message comes onto the console, it will actually let the command move to another line underneath it. All right. Same thing for the VTY lines. The login local and login synchronous. Remember, the console is when you're physically plugged in with a console cable, and the VTY lines are when you're using the IP address to access the device. So with the VTY lines, you're accessing the management plane of the device. So we need to make those keys again for the SSH encryption, or for things like VPNs, you'd make your keys as well. And you have to make sure to enable version 2 of SSH. Version 1 has a lot of vulnerabilities. And that is our basic configuration. We did that section, I'm saving it. And in the next part, we're going to go ahead here and move into the rest of the VLAN configuration on the switch and all that. Okay, so now we're moving into the VLAN configuration on the switch, as well as the trunking and all of that. First thing we're doing here is VLAN 10 creates the VLAN, and then we're giving them descriptive names for each VLAN on the switch. So VLAN 10 in this network is our office staff. 200 is our DMZ for servers, and 100 is our management device, our management VLAN rather. Okay? So that creates them. But these as well, for each VLAN, we have per VLAN spanning tree protocol. We need to set the priority to 0. That way, if in the future another switch is plugged in that has a better bridge ID than ours, it won't become the root and mess up the flow of traffic. And this becomes very important in a big network as well. But you have to do it for each VLAN because STP, it has a different view of the tree for each VLAN. Now, this part, similarly to how we made the SSID and then we applied it to a radio interface, here we're making the VLAN and then we're applying it to switch ports on this switch. So the switch port mode access means it can only belong to one VLAN, and the part there with switch port access puts it in the VLAN. Now these important commands here actually speed STP up. STP by default, at least the common spanning tree, has delays where it does listening and learning to see if there's a loop in your layer 2 network. When you enable port fast, and in this case on this range of ports, it will actually stop those stages, and you're basically telling the switch you're not going to plug another switch or device that runs STP into those ports. So that's why you need those. And the bpdu guard enable, it is a failsafe. So if a bridge protocol data unit ends up coming into that port, it's going to shut that off, and it's going to go into error disable state. But we're doing that here as a safeguard. All right. As well, though, if the port does go down from that command, you have to reset the port, and traffic will stop while it's disabled because of that. So for what we're doing now, we're doing the same thing, more or less, but we're doing this for VLAN 24 and 25. I put those in VLAN 100. Yes. No, 200. Getting confused. VLAN 200. And the commands here for the same thing. And for the same reasons. Okay. Now, in this case, we're having the server. We have on-premise servers, and we're plugging that server into gigabit 1/24 on this switch. And that port is in VLAN 200 now. But we want to make sure that server is not changed out for something else. How do we do that? Well, network interface cards and computers have MAC addresses, and the MAC address identifies that physical computer. So we can specify we only want that computer to send frames to that port. So it's a way to control computer by computer access to an Ethernet network. Similarly, how we control access to a wireless network with MAC filtering. It's the same concept. In this case, I set up switch port security. That enables it, first of all. And then after you do that, I'm going to set a maximum of 1. Now that is the default, but as I'm configuring it, I want to make sure I know what I'm configuring it. When I type it, it's easier to see and remember what I configured, even if it's default. Now, that's important. This part is one MAC address. All right, 0000, etc., and 1111. This means if any other computer is plugged into gigabit 1/24, the port will be disabled. All right, at least in the default violation mode of port security. Now, the error disable mode is going to work similar to how bpdu guard worked. In most of the modes for port security, the port will go down and not physically be enabled. You have to go in and reset the interface. And not only that, but you have to make sure you remove the device that caused the issue. In both of those cases with spanning tree or this. Now here we're going to assign the ports that belong to VLAN 100. And remember that VLAN 100 is our management. Remember what access mode does? It makes it belong to only one VLAN. And then VLAN 100 sets those ports in that VLAN. And I didn't mention, but the range command. This means anything gigabit 1/30, in this case through 31. When we're in interface config if range mode, anything we do in there affects all those ports. All right. So now we're going to set up our trunks. And these are our 802.1q trunks. This is a layer 3 switch, so that's why I have to tell it what trunking protocol it needs to use. It can use ISL or .1q. Now, there's an important distinction. When you set this to switch port mode trunk, it won't negotiate the trunk. It's going to try to trunk regardless with .1q. This means that if the other switch you want to trunk with is using ISL, it will fail because they're not using DTP. Okay, they're not using the dynamic trunk protocol. They're not going to be able to decide which they both support. But in this network, we know we set the access point up with .1q, and we know we're going to set the router up with .1q. That's why we are safe to do it this way. And remember, the trunk ports aren't going to the clients directly. They're going to go to the devices like our access point and router. And this is important too. Any port we didn't put in a VLAN, we want to shut off. That way no one can plug in and get into the default VLAN and be untagged. This part, I just forgot which range of ports I had. I had quite a few ports on that switch, so I had to make sure I remembered what ports I was putting in what VLANs and shutting down and all that. Yes, quite a delay here. I do apologize for that. But anyway, though, that is because we want those ports to be secured. So 32 and 44 were the next range up that were in VLAN 1, the default VLAN. And in this case, that was still the native VLAN. I didn't change that on the trunk by doing switch port trunk native VLAN and then changing that VLAN ID that won't get tagged. And these are just disabling the 10 gigabit ports on the switch I was using. So that section is done. We saved our config. And I'm verifying that the VLANs are all where they should be. So here we can see. Let's see. So VLAN 10 Office has these ports in it. And once the trunks come up, the trunks will be in there as well. And by using ID, when you have a lot more VLANs, it cookie cuts the configuration out for you, so it's easier to get the information. Okay, so that was our VLAN configuration and our trunks. Remember what a trunk does. When we put the ports in those VLANs in access mode, that means if a frame comes in on that port, it's part of that VLAN logically. But that in turn causes the trunk ports, when the MAC address is destined out the trunk port, it's going to put a tag of 802.1q in that frame. So even though they're going over one wire, that ID makes them separate subnets. Okay, and that works for IPv4 or IPv6. It's the same concept because this is layer 2. All right, and when trunk and trunk talk to each other like the access point to the switch, it's just already tagged. So that also means when it comes in, it knows what ports it should go out of because the traffic needs to come back in on the trunk as well. And that tag is so important. If it gets mixed up, you could have security issues. But that's how the trunks work and what the access points do. The access ports, rather. Okay, I'll see you in the next one. And we're going to go ahead in this next part and configure the monitoring and management features on our switch. So we'll see you there. Okay, so now we're going to configure our management settings. So this will allow us to monitor the device as well as get into the device remotely. Now, the first thing I did was I made a switch virtual interface for VLAN 100. And then I put the IP in. If you're following along, that is in the 100.0/24 network, and the access point was .2. This one is .3. But the idea is this subnet in our associated VLAN is just for management. So I'm going to bring that up. And this sends syslog messages to the IP we specify. And this is our logging server in the VLAN. All right, 192.168.100.254. Now, the SNMP is a way to get logging. I'm sorry, not logging information, but you're getting things like interface utilization, or RAM usage, CPU usage, things like that. And this is a way for that management station, in our case, to query the SNMP server with the community Cisco and get that information and keep us up to date as administrators of what's going on. Now, that read-only at the end is very important. If you don't have read-only on there, the management station or anyone with an SNMP client can actually connect and change the value of an object identifier. Things like an IP address of an interface, or other configuration like that, the host name, lots of things. Things we don't want, though. The only way we want to change it is if we SSH it. Okay? And again, this is our access list that's going to restrict just the subnet from accessing the device. So any other subnet, whether they do a VLAN hopping attack, etc., won't be able to get in there, because even if they swap the VLAN tag, they don't have the right subnet in the packet, the right source address. All right? But that is what we have going on, and you can see that it started the logging session. Now, we don't have the management station configured in this lab, but basically, to wrap that up, you would configure something like PRTG or SolarWinds, and you could either put that on your local network and have it go there, or you could configure another network connection like a tunnel, like an IPsec VPN or something, and have that traffic go over the tunnel to something like a remote management software in the cloud. So you have options other than just what I'm showing here. So I will see you in the next one, and we need to configure the router now. Now, I have a layer 3 switch, but I'm not using that. I'm going to use the sub-interfaces on my router. And this is important because it not only routes between these networks, these VLANs, it's also going to do the filtering at layer 3 of these VLANs. So I will see you there. Alright, so now we're on our last piece to configure, the router. So we're going to start with the basic housekeeping config, if I could speak, that we did for the access point and for the switch. Remember, enable secret protects privilege mode for the configuration changes to be made. Enter username admin secret makes username admin with a different password. Remember, use secret instead of password because secret hashes the value. Again, we're securing our line console because we don't want anyone to be able to just hit enter and get access to our configuration and everything. Now, I didn't say this before, but even if they hit enter here on the console and get in, if we have set an enable secret, they still, regardless of if it's VTY, an aux line, or console, cannot get to privileged mode without the password of Cisco in this case. And the aux line is for a modem. In this case, we still want to protect it. On the off chance a modem is used in that port, it would allow the access as before. But the enable secret would still protect it. We want to set our domain name, and generate our keys as we have done before now. And a lot of these concepts can be carried over to lots of different equipment. It's standards. So you'll see a lot of this on any kind of vendor. The main difference is just how you configure it, But yeah, that was this part. And now in the next one, we're going to configure the interfaces, the IP addresses, and the NAT and all that stuff. So I'll see you there. Okay, we're back. So let's go ahead here, and now we're going to log back in with the credentials we gave it before. And feel free to, you can also set a banner with the banner command, but I just didn't do that here. So we got to go into our physical interface, bring it up. In that physical interface, we're carving up into sub-interfaces. We're setting that VLAN tag. So when frames come out of the interface, they will get tagged with the correct VLAN ID when they go back to the switch, or if it was plugged into an access point. And also when they come in, it will guide them to the right sub-interface to be processed. So this is really what is linking VLAN 10, in this case, on sub-interface 10 with this network. All right, in this case, normally you have the third octet match if you're using a /24, but we didn't have to in this case. And because this is a private address space, and in our LAN, for our network address translation, we're going to say IPNet inside. And this puts this interface, it associates it with the private side of our network address translation. So basically, a lot of this is going to be rinse and repeat because the concepts are similar to what we did on the access point. So this is the sub-interface for 200 and encapsulation .1Q for that. Do make sure don't mix up the tags though with the interface. That will cause the VLAN ID mismatches and a lot of confusion. And again, this is linking the subnet with the VLAN. And this is our DMZ. And you got to remember IPNet inside. We got to make sure it's the private side of our NAT. Okay. And this is our management interface. And you could also add descriptions here too with the description command, because then we could say this interface is for this, that, and the other, you know. All right, we're doing the IPNet for the same reason, and now we're going to go into the WAN interface. And this is actually Ethernet on the router I'm using. So it would actually be plugged into like a cable or DSL modem, fiber, or whatever. But what I want you to pay attention to is this is a private address. Yes, it's a Class A private. But the concept here is the same whether it's a public or not. The concept will work the same way. I'm using 10.0.0.2 with a /30 mask. And this is what is in a lot of business connections with ISPs. And what you'll find is you'll have yours on the second IP on the subnet, and you'll have the modem that is also a router provided by your ISP in some cases, and it will route out to the other IP. So you have a /30 subnet to access the rest of the internet, okay, on most business connections. And on even bigger connections, you would be running a routing protocol yourself with that provider. And again, IPNet outside. This is an important thing not to get backwards. If you get it backwards, your NAT will work the wrong direction and in the wrong way. This is our WAN. So remember, private IPs, they don't route on the internet. Routers block them. So we have to say this is our outside, because when a packet comes into any of those other three interfaces, whether they're physical or sub-interfaces, the source of them, when they go out of G0/1, is going to be changed to 10.0.0.2. And we haven't set the actual part of that up yet, but I just want you to see why it's important to not mix those up. And again, as always, with any interface, make sure to bring it up. And this is our default route. And this is going to 10.0.0.1, but I want to pause it here because I'm doing something interesting. I'm adding a non-standard default route. So normally, if you're using something like this, the AD is 1 because we're using a next hop. But if you use an interface, that's an AD of 0. So the administrative distance, in other words, how the router knows what route it should trust more and use before another route for the same network. So by setting it to 150, if I run a routing protocol like RIP or EIGRP, at least internal EIGRP, on this router, it will use the routing protocol routes, like OSPF, it would use those, but if those were to fail for some reason, the router would switch out this default static route. Say a router at the ISP is running OSPF and they did IP default information originate. Basically, though, they injected a default route into their OSPF process. Well, if that fails, we would lose our default route, and if we had routers underneath this one, we wouldn't tell them how to get out anymore to the internet. So this will take over if that route were to fail. Okay, that's why I'm setting the admin distance as I am. And again, this is a good example of logging synchronous. It skipped a line for me and didn't mess up my command. So after this, we're going to set our DHCP pool up for our LANs. And these commands exclude certain addresses to be leased. So in a network, it's a bad idea if clients lease the default gateway because you'll get an IP address conflict. And even maliciously as well, this could still happen, but that's why you have other mitigations like DHCP spoofing and things. But we're excluding not just the IPs on this router, we're also excluding what is the server's IP as well. And we're excluding the management station. Now, if you're not running DHCP on a segment, you don't necessarily have to exclude it. It doesn't really hurt anything. But, if you're going, by the book, obviously don't type one that you're not serving DHCP on. But this sets up the pool. And as I said, you'll see other equipment have different configuration parameters. So when you go to do another config on that equipment, you get a little backwards. And up there I added something I shouldn't. But anyway, though, the default router is just the gateway it will give clients, and the DNS server is the server it will give them. They can still use their own, because in this case we're not filtering on that. But this is just the pool for the office and for that VLAN. And it doesn't matter if they connect on the access point or on the actual plug into an Ethernet port from a cubicle in an office. It works the same way. Those frames will get tagged and they will get IP information from this DHCP server. Now, if you did use IPv6 on a subinterface, you do got to make sure the VLAN tags are working, because they have to get the network portion of the address from the subinterface. They have to send their solicitation message and get a reply from the router. So now, speaking of the NAT, though, this access list isn't filtering like our management access list was. And it's not filtering traffic on an interface. Like, it's not filtering packets flowing through an interface. This is actually a type of access list that classifies traffic. So it's similar to quality of service, but what we're doing with this is saying what traffic the router should NAT. Because you don't want it to NAT just any traffic, because then you'll have crazy things happen. If things were spoofed, it would still NAT it and things like that. But the 3 VLANs, 3 networks we have, we're NATing them. Okay, we're saying this is okay to NAT. All right, and this part is where we're actually mapping them together. But there's very important things about that command. The IP NAT says it's the IP NAT inside it's working on the inside domain of NAT. Our source can either be list or static, and we're referencing our access list we made. So it just means these 3 networks will be applied. A NAT will be applied to them. Interface G0/1 is, in our case, we're using NAT overload. We only have one public address, and we want all our clients in those three networks to use the one address. So instead of typing it, we're actually using interface. So it will use whatever IP is put on the interface in this case. Okay, it'll work for static, etc. But if you have like a /29 given to you by your ISP, you could use a pool of those addresses that are public and use different ones for different servers and things like that. But that would be an example of dynamic NAT config. But overload, if you don't use overload here, any of these LANs, if a packet is received on the inside interfaces, the first packet that creates a NAT translation will be the only client on the network that can use that IP. So it can use only all of the 65,536 ports. But overload changes the source for each connection, the source port, as well as the source address. So all these different clients can use different port numbers to distinguish the translation. Okay? Because if you don't add that, you only get one client that would have access to the network. Now, these are actually because we have that DMZ we were talking about. These are the port forwards of the traffic that I need to get into the server. Okay? And this is destination NAT in this case. The other above that is source NAT. In this case, and we'll pause it after I finish typing them, what we're doing instead of a list is just saying I'm statically defining this. TCP is the type of protocol. All right. And this first IP address is going to be what is referred to as the inside local. And that means in the inside of the network, the private side. This is what we want this to map to. And the first port is the destination, the port number that should trigger this translation. We have 80, 25, and 993 in this case. But the interface, G0/1, specifies the inside global address to change it to. So outside local and outside global, the source in this case with destination NAT will stay the same, but we're changing it to be that address when it goes back out. So we're saying this address here maps to that interface's address. So that way it just seems like it's the one public address, but it's not really. These three types of traffic will actually end up going to that server behind our router. Okay? And NAT can be confusing at times, definitely. There's a lot of different things to it, lots of different ways to set it up. But here I'm just verifying with the inside and outside commands that I have my interfaces in the correct domains, and I do in this case. And there's our access list we're referencing. And I also am going to verify my translations. And this isn't the same as the dynamic ones that will happen, but what's happening is we are setting these three, and that's how you see them. That's the inside global. The global represents that IP on the inside to the outside world. Okay? Now, outside local, they don't have them because we didn't use outside in that command. But as soon as you see other translations come in for the source NAT part, you will see outside local and global fill up for the servers that are being connected to. Okay, well, that's the main stuff on our IP addressing and NAT and our DHCP. So in the next part, this is where we actually configure the security. Because this router, in this case, has security on there. So we're going to enable those things so we have more security in the network. So I'll see you in 1 second. Okay, so now, after configuring all the IP and routing and all that, we're going to configure the security. So this is all what's going to control where traffic can flow and everything. So the first thing I'm doing is making an access list that's going to stop traffic from the WAN by default. Okay, it's going to deny everything. But why I'm adding these permit TCP any rules is I want packets going to those 3 ports we're using NAT for to be allowed in, to not just be dropped. And now we're going into the interface, and then we're going to apply the access list inbound on that interface. Now this is CBAC, or context-based access control, and we want to make 3 types of traffic to monitor. We're doing UDP, TCP, and ICMP. The thing that's important to understand is this makes our router work at layer 4 as well. And now it's going to keep state information about connections. Because like the sequence numbers and acknowledgement numbers in TCP, for example, they have to match up correctly. Otherwise, the session is not allowed. In other words, it will hit the deny access list. But we're going to explain more about that when we go ahead and apply it. So this will inspect the traffic, but how we will place it with IP inspect only allows traffic being routed out the interface to be kept track of. If we said inbound for UDP, TCP, and ICMP, any computer on the internet that sends to us would actually create state in the table, and we don't want that. We only want to protect our clients. So what this means is when the clients send, it's going to keep track of it, and they will bypass the WAN deny list because of the fact they're in the state table. Okay? And again, the DMZ here, this is our restrictions on the DMZ. All right, so what we want to do with this one is actually extend it because we need to filter source and destination, even though we could do protocol and port numbers as well. So in this case, I'm actually being heavy-handed in denying all types of traffic from the DMZ, sourced from the DMZ, going to the office, okay, and going to the management VLAN. Remember, because we have VLANs, it's all on one physical wire in this case. So we have to have this, otherwise it would just route. It's the same thing if we just used physical interfaces. They would just route between them with no firewalling. And the permit any is important, because if we don't do that, it actually allows, it would deny everything else because it has an implicit deny at the end. Okay, so we're denying these 2 types of traffic, but this means it allows it to talk to anything else. Okay, because if we didn't have that, it won't be able to reply to clients on the internet trying to get access to the services. But remember, we go into the sub interface to apply this, not the physical one in this case. But the concept by filtering with the IP addresses is the same whether it's a physical interface or a sub interface. And these here are just more for security, so there's no replies to traffic being dropped, since tools like Nmap can use those replies to gather more information about the device that's being scanned. And as well, I disabled CDP because we don't want that traffic going upstream to our provider. Right, and what we want to look at here is I'm just verifying the outgoing access list is WAN deny, and the inspection rule outbound is the WAN insp rule we made. And verifying again our access list on the sub interface. All right. With that though, in the last part for our router, we're going to configure the monitoring configurations. So I'll see you there. Alright, so the last thing we got to do with our router is configure all the monitoring and management restrictions. So what we're doing here on each interface is we want to collect flow information for the types of traffic and amount of that is going through the interfaces. And ingress and egress means in and out, so it'll be able to collect the information for both directions. And once we've done that, we're going to send the information and export it to our management server. And then that management server is running a NetFlow collector for that traffic. And the cool thing is it can get the information and put it in graphs and things for you. But having it centralized scales well to a big network. Same thing with JFlow with Juniper equipment. It's the same concept. Even OpenBSD has PFFlow for those kinds of things. But there, we're just setting the version and the destination of the management address of the server and the port number. All right, and here we're doing the SNMP configuration as before, and our syslog remote logging, just like before. And we'll be able to go in there and see those messages on the network system, the network logging system. And we only want to allow the management VLAN, so that IP network, to talk to this device. So that's why we're configuring the same thing. And we did that on our access point, our switch, and now our router. And that's the reason why. But, the access class is going to inspect packets coming into the line, and then there you go. So we'll do one more save, and at this point, what we've achieved is we have two SSIDs. If you connect to management, you're going to be in VLAN 200, and if you connect to Office, you're going to be in VLAN 10. I'm sorry. Management is VLAN 100. Keep getting it backwards. And as well, though, if you connect to any of the access ports we configured, you'll be in that VLAN. And the trunks will work the same way. So with all that, though, I do hope you really enjoyed this lab and everything. So, as always, I'm Tyler with T-Tech, and have a very nice day.